time to begin. Now count it in. 5, 6, 7, 8.
My boots scooting baby is driving me crazy. My obsession from a western, my dance floor date, my rodeo Romeo, a cowboy got from head to toe. Wanna make you mine, better get in line. 5, 6, 7, 8.
Okay, so this is our SPSS screen, and the first thing that we need to do is make sure we input the variable into the correct place. So this is just the data view, as you can see from the bottom left hand corner. What we need is the variable view. So we just click on that there, and we type in our variable, which is attitude to crime, and it doesn't like spaces, so if you come up with an error message, don't panic. Okay, I always make spelling mistakes. Okay, make sure it's numeric in nature and that we add the values. So if you go back to the example, you'll recall that 1 represented not problematic, 2 represented somewhat problematic, and number 3 represented very problematic. So we just click add there and OK. Because we've got categories, we need to enter the measure. So if you look at the icons, they kind of give you a clue. So we can see that 3 different circles, they're very separate. So we think, yeah, that's categorical. So it would be nominal data. And then we click back to the data view, and there you can see our variable, and we're ready to input the data. Okay, so because we have only one variable, and the variable is non-parametric in nature, so you may need to refer back to your lecture or your lecture slides on tests of normality and distribution. But essentially what we need to count is the number of 1s, the number of 2s, and the number of 3s. Then we go back to SPSS, and what we make sure is we go back to variable view, and we add a second variable, which we're going to label frequency. You could label it number of, whatever makes sense to you. And it's just going to count how many 1s we've got, how many 2s, and how many 3s. So therefore it would be scale data. Okay, we have no values, and then we would go back to data view. So I'd counted 6 number 1s. So if we go back to the data set, we can see we have number 1, 2, 3, 4, 5, 6, and so on for the number 2s and the number 3s. And a simple way to check that you've got the right amounts is does it come to the total number of participants? So 6 plus 9 plus 15 does indeed equal 30. So in instances like this, we need to weight the cases. So this is when you've got a goodness of fit and non-parametric data and only one variable. So we go to data at the top of the screen, and then go right the way down to weight cases. And we want to weight the cases by frequency. It's not attitude to crime, but by frequency. Okay? And then click OK. Okay, so this output window will pop up, and it's just telling us that we have ordered the weighting by frequency. We would then click that down and continue with the analysis. So we would go up to Analyze, right the way down to Non-Parametric Tests, across to legacy dialogues, and there we can see the chi-square test. Yes. So no, it's incorrect. So what we want in the variable box is the frequency. And attitude to crime. Okay, and then click OK. So we get an interesting table here. So again, it's just confirming for us that we had 6 number 1s, number 2s, and number 3s. And then it gives us the chi-square statistic. So we need to make note of the chi-square value, the degrees of freedom, and the significance or p-value. So don't worry if you're confused. We're going to go through that now on the next slide. Okay, so this is how we would write up the chi-square test in the results section of a practical report. So you would state that a chi-square test was used to explore differences in the extent to which crime was perceived to be problematic in the West Midlands. Whilst the score for very problematic was highest, you can see we've got the number 15 there. So if we were to go back to SPSS, we would see that the highest was for very problematic. And greater than expected, there was no significant difference between the 3 categories measured. And this is the statistical notation that you would present. So this is the symbol for chi-square. We've got the degrees of freedom here. Then we've got the chi-square value and then the p-value. Okay. So if we just go back to SPSS and the output, you can see that I've taken the chi-square value there, so 4.20. That's gone there. Okay, that's the result of our chi-square test. The degrees of freedom is 2. So I've put that it's 2 there. And then the significance or p-value is here. So we need to decide if it is significant or not. So if the number here is greater than 0.05, then it is non-significant. If it is less than 0.05, it is significant. So hopefully you'll be in agreement that 0.122 is greater than 0.05 and is therefore non-significant. So although we had these differences in frequency, the differences were non-significant. Okay everyone, so you may have already done the first one. There is a second test that you can perform, and this is when you've got more than one variable. So it's important that you understand this. It may come up in your exam, it may not. However, it's essential that you understand the concept. So in this example, we have 2 different variables. We've got intellectual capacity, so whether there is an intellectual disability, or whether they do not have an intellectual disability. So you have categorised those who have as 1 and those that do not as 2. And we want to see if there's like a correlation or relationship between those that do or do not and whether they are disciplined for arson or if they are not disciplined for arson. Okay, so again you can see that discipline for arson has been coded as 1 and those that have been not accused have been coded as 2. So again, we go back to SPSS and try to put these variables into the dataset and make some sense of the question. Okay, so this is the data. Again, we've got participant number. That is not a variable, so ignore that completely. So we've got offender type. So all those that were 1s were those that had an intellectual disability. And all the 2s represent those that did not have an intellectual disability. Then we have a second variable, discipline for arson, and the 1s were those that were disciplined for arson, and the 2s represent those that were not. So we have 30 data sets. So we have 15 offender types there, and another 15 offender types there, and 15 units of data for discipline for arson, and another column at the end there. Okay, so this is what we need to put into SPSS. Okay, so as you can see, we're back to a blank SPSS dataset. So we're on data view at the moment. So remember, we've got to put the variables in first. So we need variable view. Okay, so you may need to look back to the example. That's completely fine. I believe it was disability type. I always mistype. Dear me. Okay, so again, check that it's numeric, and again we have categorical data. So the data is coded to 1s and 2s. So again, just for your reference, if we just go back to the previous slide, you can see that, yes, those with an intellectual disability were categorised as 1. So we place 1, and the label would be intellectual disability. So don't worry if there's spelling errors, as long as you can understand it, it's fine. Then number 2, no intellectual disability. And click add. So basically we want to see if there's a correlation between those that have a disability or not, and whether they are convicted of crime. So if we go back again to the dataset, just remind ourselves, those that were disciplined for arson were coded as 1, and those that were not accused were coded as 2. So we could label the variable as disciplined. Again, it might be spelled wrong. My spelling is getting terrible. So 1 was, I have to check myself. Yeah, disciplined. And number 2s were none. And click OK. So we've got both variables in. Okay, so the measure, so by now you need to be taking care that you understand these concepts. It's going to be really important for your exam. So because we've got categories, again, look at the symbols. Okay, so we've got 1 and 2, so we go for nominal. Okay, it's categorical. So we've got 1 and 2. And the same for whether they were disciplined or not. And go back to data view, and there you can see we have our 2 variables. So what we then go to is back to the workbook. And you can copy, just highlight that there, right click and copy back to SPSS, spread it across the 2 rows and paste. Then back to the data. So we want to ignore participant number, that's not a variable. Again, highlight them, copy. Make sure you started at 15, that's correct, and paste. So definitely check that you've got 30 units of data, because we had 30 participants in the example. Yeah, so everything should be correct there. So we've got our data in, ready to analyse. Okay, so because we have two variables and we're looking at the association between the two, we run a slightly different chi-square analysis. So we would go to analyze, across to descriptives, follow it across, and then down to cross tabs. So you can see I've already put disability type into the row box and columns discipline. Okay, click statistics, ensure that the chi-square box is ticked, click continue, and we might ask for a bar chart. This will just display the frequencies of the different categories for us so that we can actually understand the data. It's okay creating this output and putting it in the statistical notation, but what does the data actually mean? So that bar chart might help us to understand the data. And then we click OK. Lovely. Okay. So what we need to look at is the Pearson chi-square value here. So if you refer back to the correlation coefficient, that will help to see if the value of the correlation is significant or not. Okay, so in correlation terms, this would be quite a weak, very weak positive correlation between the two variables. We've got the degrees of freedom there, DF, yeah, and then we always look for significance, and that's the p-value, 0.705. If we scroll down, we can see the bar chart. So we've got disability type, so whether they had an intellectual disability or no intellectual disability, and then the blue columns represent those that were disciplined, and the green represent those that were not disciplined. So you might just want to have a look at the data. So there are similar trends going on here, isn't there? So both the discipline columns are significantly, shorter than the non-disciplined in both scenarios. Okay, so it almost appears just visually that there was no real difference between the disability, whether they had an intellectual disability or whether they didn't have an intellectual disability. Okay, so this is how we would write up the results. So we'd say that we had conducted a Pearson chi-square test to determine if there was an association between intellectual disability and accusations of arson. So do we think that people who have an intellectual disability are likely to be accused of arson to a greater degree than those that do not? Okay, so try and put it into context. And we were making counts and frequency of cases. Okay, there was found to be no significant association between the two variables, meaning that someone with intellectual disability was no more likely to be accused of arson or disciplined for arson than any other prisoner. Okay, so you can see there that we've put it completely into context. This statistical notation here is the chi-square representation. Just accept it, don't question it. Okay. The degrees of freedom I've taken from SPSS. So if we go back to the output, I can see, yeah, the DF, the top line here, was 1. So I've put that into my statistical notation. I then need to present the chi-square value, or the Pearson's chi-square value, sorry. That was 0.144. And then I presented the significance, or the p-value. So in this case, it was 0.705. And again, hopefully you can see I always look for significance, and there we have it. Okay, so if you're in agreement with me, you'll recognise that p is greater than 0.05, and it's completely fine to present the greater than symbol or the less than symbol. However, you can just present what P equals. So because it's greater than 0.05, it's non-significant. So just to help our understanding, as outlined before, we could input a graph. We've labelled the axes, so we've got the disability type, frequency, the y-axis. We've labelled the different, clusters of bars, and we can see that there is, they're very comparable, that they're very similar, which supports our no significant result. So if you were to do this on your own, the only thing that I would add is a title for your graph, which is placed underneath, surprisingly. And we always call graphs figures. So you would put figure 1 displays the frequency differences between those that had an intellectual disability or not, and those that were disciplined or non-disciplined for arson. Okay, so always include a clear title for your graph. Okay, so fantastic. You've reached the end. You've seen two examples, a chi-square of goodness of fit and a chi-square of association. And if you really don't appreciate SPSS, then that there is the equation to find out the answer by hand. So always be grateful for SPSS, basically, unless you love maths and you want to do equations in your spare time. I don't know, it might be your thing. Anyway, thank you for listening, and please let me know if there's any feedback.